Hello everyone. So today I will be performing a hypothesis test using independent samples, t-test, and SPSS. Let's consider a scenario where uh, we hear or we read somewhere that the height of the population in Puerto Rico and Dominican Republic is the same. In other words, the people are generally have the same height in both countries. That's a null hypothesis or an accepted hypothesis. So we say, well, maybe that's not generalizable. Maybe that's not valid hypothesis. We would like to introduce a new hypothesis. So we draft that's where the alternative hypothesis comes. So we say in the alternative hypothesis that the heights of nationals from Puerto Rico and Dominican Republic are different, meaning people from both countries have different heights. They're either taller or shorter. In other words, it's either greater than or below the population average. So the type of test that we will do in order to determine our hypothesis is called the independent samples t-test or two-sample t-test. We will be looking at both sides of the tails. In other words, we will be looking at either the new average or the difference in an average is greater or below. Either one of them is taller or the other one is shorter. So that's the type of test we will be performing. And the significance level, as always, because this is a sociology related or socioeconomic related topic, we would like to keep the we would like to keep the we like to keep the significance level at 0.05. In other words, the p-value has to be below 0.05 in order for us to be able to reject the null hypothesis. So I'll be performing this test in SPSS. So what I would do is, let's say I go and perform a survey of the population in both countries, and I randomly select 15 people from country one, Puerto Rico, and then 15 people from country two, which is Dominican Republic, and I record their heights, and which is the measurement unit is inches. So and then it turns out that the average height in Puerto Rico is 66.4 inches, and the average height in Dominican Republic is 73.7 inches. So we see that there is, some good amount of difference between the heights of both countries. But we would like to check this. We would like to test this difference to see if this difference is statistically significant. In other words, can we generalize this difference to the overall population in both countries? Is this by a chance? Is this in an accident that this happened? Is this just a product of a chance, or this is actually a generalizable information that what we can actually use it with confidence that yes, there is difference in the heights of both nationals. So we go to SPSS. I have the information already. I have the information already imported here. So remember, in the variables, both variables will be numeric. For the country, you can always go to values and put value 1 for country 1 and put value 2 for country 2. It helps to be able to read the information once you produce the output. So on the data view, simply go to compare means, analyze tool, compare means, and click on independent samples t-test. Over here, what you will see is these are both of the variables under consideration. We will put the measure variable, which is height, onto the test variable box, and the control variable or the group variable will go to grouping variable box, and then we will define it, by the two categories of one, which is Puerto Rico, and two, which is Dominican Republic, and then click on OK. Always, since we have selected our p-value as 0.05, then we would like to put 95%. This is the reverse of the p-value, a CI of 95% interval, as a confidence interval. So click on OK, and bingo, we go to the output. So this is the result of our test. So as we can see, the height, the mean or the mean is a statistical word for average for a sample, and mu is the population parameter for average. So remember those acronyms. So the average of height in Puerto Rico is 66.4, and the average of height in Dominican Republic is 73.6 or 7 if we round it to the nearest decimal. So it's the difference there, standard deviation. This will be I'll have a separate video to explain distributions and standard deviation on a univariate data statistical analysis topic. This is where we need this is where we get our information from. As you can see, Levine's test for equality variance is 0.316. This means that we can keep our assumption that both of the variables actually have equal variances. In other words, there's no statistically significant variant. They don't vary statistically significant. So that's a good news. But that's not where what we're looking for. We're looking for T because we are looking for the equality. We're looking at difference of the means, not the difference of variances. So the difference of the averages. So the difference of the average, we have a p-value of 0.01, 0.011. So this p-value is below our designated p-value of 0.05. So in this case, we can actually reject the null hypothesis that says both of the nationals in both countries have the same height and say that no, actually, there's statistically significant information to claim that they don't have the same height. Um, Instead, the Dominican Republic, the Dominicans are taller than the Puerto Ricans. So mean of difference, standard error difference. These are a little bit complex topics. I'll have separate videos about them. Pretty much, the mean of difference is how much the average differ, how much they are they different from each other. As you can see, this is the difference of these two averages. And a standard error difference allows us to be able to build a confidence interval boundary between the lower and upper boundaries. So 2.66 will be is multiplied by the z of 95%, which is 1.98 or 95, and it'll produce a lower boundary of 12 and an upper boundary of -1. I'll have a separate video about this. This pretty much standardizes the difference in the mean by 90 by the lower and upper boundaries. But the most important thing that comes out of a independent samples t-test is the p-value. Since our p-value is again below 0.05, we can actually reject the null hypothesis. So we can go back to our study page and and write the test result, which I've already written for the sake of making this video shorter. We say the independent sample t-test. In this case, we put the t result here, which is minus 2.712. So minus 2.712, p-value below 0.05, revealed that there is statistically significant difference between the heights of Puerto Ricans and Dominican nationals. Therefore, we can reject the null hypothesis and claim that the difference in the average height of the Puerto Ricans 66.4 and Dominican 3.7 is generalizable to the entire population in both countries. That means that the difference that we can observe here is generalizable, is statistically significant. In other words, there's a good amount of chance that you would see this difference uh, 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 if you randomly pick up any sample from the population and check their heights. This was the end of the video. I hope this was helpful. Thank you.